0.33 kilogram per normal cubic meter. If we use recommended draft, I think we can see. Recommended draft 30 millimeter water volume. That gives a chimney height of 75 meters. And a chimney stack height 20 meters. We have a draft at 8 millimeter of water volume. The missing draft is length 22 millimeters. An induced draft fan can compensate for the missing vacuum. It's recommended to have a variable frequency drive on the ID fan, alternatively an automatic damper, and the ID control system must secure a constant vacuum in the furnace. Now we start moving into discussion about the control system. What should the control system do? And the idea of a control system is to have uniform operation of the boiler, have a uniform combustion. And if we try to run with a constant vacuum in the furnace, then the forced draft fan, if we have, I saw a boiler on a power boiler where they were running the forced draft fan according to the steam pressure. So when the steam pressure goes down, then the forced draft fan goes up, produce more air for combustion, so they can burn more biomass and generate more steam. And then when they reach the pressure, then the forced draft fan reduces speed again. But this means combustion control is not very accurate. Fuel feeding was the same all the time. Yeah. Then they had problems with the neighbors because a lot of black smoke was covering the whole neighborhood. So they put a camera on the chimney, and then it was a kind of semi-automatic boiler control. The guy was sitting looking at the camera, and then when it started to emit black smoke, then he changed the set point. So he was sitting with a finger on the set point, adjusting it. This is not the best way of doing it. It's better to use a variable frequency drive, frequency control on the system, and then run it according to constant vacuum, and then adjust your fuel feeding and adjust your forced draft according to the oxygen content. If you the combustion air, if that is controlled by oxygen in the flue gas, then there's a lot of things happening inside the boiler until you measure outside near the chimney the oxygen content. So setting up this system, you would need the PID control, where you can adjust the parameters about the time from you measure the signal and until it happens inside when you change the set point in the inside the furnace and outside at the chimney. But it's possible to do it. Then back here to the chimney, stack diameter and the flue gas velocity at the outlet from the stack should be in the range of 15 to 22 meters per second. Admitted, I have made some with 24 meters per second. Then you can throw the gas, the flue gas and the particulate matter can be thrown up higher, and that means it's getting diluted and spread over a bigger area, so it acts a little bit like a higher chimney. Taking a look at this example here, 10 ton saturated steam per hour, corn cobs on a chain grade, 2,240 kilogram dry corn cobs. This one. You can then normal cubic meter of flue gas, 15,300. Cell B36 in flue gas. You can also, if you click at it, so when you get the CD and if you start playing with the program, you can always find the link up here.
Yeah.
And that means if you want to use your own specific fuel and setup, you just go and change it from the very beginning. This here gives at 180 centigrade, you see up here the calculation. This here absolute zero and the 180. Then we have 25,400 cubic meters per hour that's going to pass through this chimney. That gives 7 cubic meters per second flue gas at 880 centigrades, and with 18 meters per second of velocity, we have an area, a diameter at
converted into data.
Yes.
From the area. Okay. 701 millimeter.
Yes.
710 millimeter.
There might be local requirements related to stack heights. The stack height should always be higher than populated buildings near the stack. If you have certain wind conditions, you should make sure that the flue gas is not going into a residential area or an area where people are working or living. Depending on the neighborhood, the stack height between 25 and 30 meters is recommended. Flue gas loss. Now we are starting to move into efficiency system. We have this here, we have seen this already. This one, the flue gas amount for rice husk, for corn cobs, rice straw, coal, oil, the theoretical, the actual. This here calculation you can use for solid fuel, L0 for solid fuel, this one for oil, flue gas energy at 200 degrees Celsius. We've seen this before, the 34 kilocalories. Then if the air surplus goes up from 1.4 to 1.6, we increase the flow by 14.3% at 180 degrees Celsius. This gives 69 kilocalories per normal cubic meter of flue gas. If we try to change, say, the temperature is 200, then it's increasing quite a lot. Can we reduce it to 150? Make an example here, and this can be reduced, but we have seen the modern boilers running with very low, they're running with 1.2 to 1.3. You can see the loss going down, keeping here, it's really worth to minimize the air surplus, go as close as you can to low oxygen in the flue gas and still also low carbon monoxide. Try to keep the carbon monoxide, I'd say it should be possible to keep it below 250 parts per million. Going here with biomass fuel steam boiler, saying 80% efficiency, steam output 10 ton per hour, fuel input 837 kilocalories of fuel per kilogram steam, means total fuel need 8,375 kilocalories. Biomass fuel, good calorific value 3,600. Total biomass fuel demand 2,300 kilograms per hour. Flue gas amount in normal cubic meter. Total actual flue gas amount. Flue gas loss with increased air surplus means we are losing 11% if we are going with increased air surplus. Here, running with incomplete combustion, if we can run with 250 parts per million instead of 5,000, we have a loss or reduced loss at 2.40. If this one is only 1,000 ppm, then it's less, much less.
Fuel saving, fuel cost saving.
Yeah, yes, fuel cost saving. And right here with this setup, it gives 5%. 5%, yes. Yes.
This is the combustion air. What is the temperature of this combustion air?
What is?
The temperature of combustion air.
Economizing inlet or outlet? Inlet is 230 degrees Celsius and the outlet is 150.
Yes.
And if we, how much will be the efficiency improvement if we increase the temperature of the combustion air?
How will increase the temperature of the gases? From the boiler we are getting 230. The rest of the energy is absorbing in the boiler.
Yeah, it's absorbing. But what is the percentage? If we increase 30 degree temperature, increase in combustion air, how much percent will be the improve in the efficiency? 1%. 1%. 1% with the 30 degree temperature. Okay.
You can.
How did you teach us how to design economizer? Economizer design is also included in your training program?
Yeah, there's. I think we have here heat recovery boiler, you should make your